make sure it's real before I used to use GIS at work and never thought it would be something like that. Yeah. Well, that's my first exposure to the GIS. Start real. But that is so much. I mean, it was huge. Like rain map. I've never done it. I always just use it. Probably no end of things, could be bad. So I used, I think, maybe 3 of the 500 buttons that were on the on the interface. Yeah, that's a pretty complex interface. Yeah. Yeah. How far can you go? So how far do we go? Yeah. Okay. The other way, I guess the round things. Great. Right. Actually, great job. Hand is over here. I'll leave it. I'll let you know that this way. You made the damn cry down. Good there? Good. Okay, so we got the leg. Okay. So yeah, the adventure continues. Okay, sometimes we got observations. I got a bunch of, and then. Yes. I take from. Oh, yes. It's cool. You hit retirement. Yeah. My president. Their ass is good. Oh yeah, he would. Well, that's my picture. That's the thing with it. Nothing. Where did you know? I don't explain myself. Oh, some of the back I got was very there's some suggestions to do. And not so much with our weddings. Yeah. Or what your actions. Yeah. It's very yeah. This is very hey Chris, you've been here a long time. Excellent. Happy New Year. So we're good. Good to see you. Good to see you. We're all on go. Awesome. So scary. We should really knock out the emails on that whole conception for the year. Compared to what I used to different fall off. Yeah, I was gonna send them an email and out. But Dave was saying they cannot Friday the 13th. No, they would not. Yeah, like, yeah. That's his asking. Yeah. Why prod to God? Yeah. There is some luck involved. Yeah. It's a lot of finger crossing. That's not 24 seconds? No, it's 7. Yeah, 24 seconds. It's good enough. I think that's probably a good idea. Yeah, that's a good point too. And I mean, okay, the public feeling. Okay, I've already we're all connected. So thanks, good. Awesome. Thanks, Chris. Yeah, I mean, based on the feedback and conversation, like probably 8 or 8 with some for various reasons. Yeah, that's like criteria or so. Then we sort of went quiet. We're starting to see that. So yeah, we need to. Yeah, there's lots of training. People like places. You know, like this old well, at least the majority is. Yeah, no, I totally agree. Yeah. So the first one's about the Brent Crater. Yes. Yeah. It's interesting. It must have been very deep. The only time I watched the no, yeah, there's an area that. Yeah, and this is old too. This is basically metamorphosized bedrock. This stuff's a crater for the slime bit. Yeah, and yeah, it's in grown more. There's one area you swear to. Yeah, it's orange, but there's a lot of it's brownish sort of. Well, it's basically granite that's been cooked. Yeah, yeah, and it's I mean technically they call it microclimate ice, which is microclimate mineral.
Hello, just testing my microphone. Can anybody hear me?
So yeah, that's what helps give it the reddish.
Yeah, I hear you fine, Richard. How about me? Am I okay?
Yes, I can hear you too.
Okay, well, I think I'll just vanish into the network word work then.
Mic down here is good, Chris.
Yes, we're talking. All right. Good. Keep that on me. They don't know about it, and it lasts like the original. Yeah. So I was asking. And then if you want, I can do another front here. Okay. Thank you. Sure. Yeah. Tonight's is a little bit. So we're okay. Ladies and gentlemen, keep your hands together. Well, I can do that. Wanna lead that back? I could have wireless like it ever. And podium can go up on the right.
I'm cool. Good to go. All right. Maybe we can dim the house lights. All right. Well, welcome to 2026 and the January meeting of the Ottawa RASC Center. Special welcome to all our members present and any visitors that have joined us tonight. And also a welcome to RASC members that have joined us via Zoom from the many centers across this lovely land of ours. There we go. And just a reminder for those that are on Zoom, you can use the Q&A function to ask a question of the speaker. And notice that the chat box comments can be seen by everyone. Also that the raise your hand function in Zoom is disabled. We'd like to acknowledge the trust placed in us by our First Nations with our ancestral lands and skies on this site. And tonight's agenda is as follows. I'm obviously doing the introductions, and Dave will follow up with January skies. Hopefully we will get some clear January skies. December has been pretty dismal. And our first speaker, our main presentation is from Chuck O'Dale, who is going to talk to us about the Brent Crater. And part of his talk will include our expedition to the crater back in May of last year, where half a dozen of us ventured down and did a nice gentle walk through very bushwhacky forest to find a mystery canyon. I'll let Chuck run with that one. Then we'll have a break, and Jim Sophia will do an Astrobit segment for us. He's got some wonderful imagery of solar coronals, happening on the sun, through the sun because of the sun's activity. And then Jonathan King will present his first installment of the Frontiers of Astronomy segment, which he introduced last month. We also have a few observation reports. Must admit, it's a little scanty this month. For those of you that do stick your eyes up to the skies there, November and December have been rather disappointing. So hopefully we'll get some clearing coming up soon. And then Richard Taylor will do our monthly observing challenges, and we'll wrap up with a few announcements. So, welcome to our new members. We had 119 new members join us in 2025, and that's lovely. And they just keep on coming, which is nice to see. Any new members in the crowd tonight? We got a couple of hands up there. Well, welcome. I hope you enjoy yourselves here, and I think we can keep things interesting for you. We have lots to offer in the center. All right, without further ado, Dave will show us about Ottawa skies. Here we go. Welcome.
Thank you, Paul. So here are the Ottawa skies. When we have the meeting pushed out by another week, unfortunately, there's a number of slides where I sort of say, aha, you missed it, but I mean, that's par for the course. So first of all, the moon phases. So we had a full moon, supermoon on January the 3rd. We have the new moon on January the 18th. And the full moon was known by early Indigenous tribes as the wolf moon. It's also been known as the old moon and the moon after Yule. We had the Quantrids meteor showers. They were on, we can't see the date here because the slide is over top there, Chris. There we go, January 3rd and 4th. They're still up there. They were left behind by, hang on a second here, I'll start reading my notes, by an extinct comet known as the 2003 EH1. It peaks on the 3rd, but it will be visible for a period of time. Sunrise and set, the days are getting longer. Our shortest day, of course, was December the 21st. Mercury is not visible this month. It's rising and setting with the sun. Venus is also rising, and all these planets like to hang close to the sun this month. It's pretty dismal. Jupiter, visible in the evening and through the night, and it's at opposition, which is closest to the Earth on January the 10th, which is tomorrow.
just in time for the rain and clouds. Saturn visible in the evening right now. Uranus is visible in the evening, and Neptune is visible in the evening. And of course, with all the with the solar maximum going on right now, we have the northern lights poking up every once in a while. And I thought this next slide, thanks to Chris, sent this to me, is appropriate. Thank you.
Okay. Thank you, Dave. That's great. I often wonder how those things formed. All right, Chuck, the long-awaited presentation of the Brent crater. There you go,
A
sir.
couple already. Well, thanks, Paul. And poor Paul, I dragged him through the crater as well, so he's a survivor. Well done. Okay, this is my one of my first slides when I used to do these presentations. If you look at craterexplorer.ca, the website there, this will kind of document my 30-year experience with the RASC. And during the time here, I have to say I've experienced a lot of good support from the club and a lot of professional support as well. Simon, thank you. I received this here picture actually was when I flew down to Puerto Rico. I wanted to investigate a crater down there, and somebody built a radio telescope in it. I don't know if you recognize it's the old Arecibo radio telescope, and that's me, what, 20 years ago now, almost 25 years ago. Holy mackerel. Anyway, let's see if we get it going here. So, one of my hobbies with that airplane, I thought, well, I wanted to actually just casually fly over every impact crater I could find within range of my airplane. And the Brent crater was my first project. And this is my one of my first pictures coming into the Brent. This was a long time ago, 93. And it was kind of not very spectacular, but the more I find out about it, the more interesting it gets. But I want you to note, before we go in here, let's see if we do this, there's this dome right here. It's almost like a central peak, but it's not. And I thought, wow, when I flew over that, if I go to that central peak, I can get an awesome view of the crater, but we'll find out about that in a bit. So, from the ground, the best view of the crater is from the lookout there. And again, the dome, you can just barely see it there. And that's sort of a raised dome. And in the background, the trees in a very, very far background is the far rim. So it is a fairly substantial crater. So this, I'll give you the Coles notes here. Essentially, time of impact, late Silurian, early Devonian, 396 million years ago. Trilobites were the most advanced life form at the time. Europe and America were just about to collide. Ontario was approximately at the equator. Plant life was just beginning to appear. So, this is kind of a cool thing, but I hear you asking, well, how do we know that this thing is a crater? And how do we know that is actually 396 million years old? Well, let me tell you. First of all, a little bit of history. You probably noticed on the moon that virtually every crater you look at, almost all the craters you look at are circular. And you could say to yourself, well, this can't be, because that would imply that every impact is 90 degrees. But that, in fact, is not the case. There are some craters that are caused by an impact at a very acute angle, less than 5 degrees, 4 degrees off the moon's surface, which gives you the elongation type craters. But majority of them, no matter what angle they hit on, they're always circular. Now, why is that? Well, first of all, the penetration, you're looking here at a nanosecond. This projectile, when it hits Earth, is going at 14 kilometers a second, up to 70 kilometers a second. All depends on which way the angle they hit. They're catching up to us or dead on collision. But I want you to take a look at this. Is a nanosecond after the impact. And just remember the impact ejecta there, or the the impact melt is what I wanted to say. That's kind of important coming up. And about a microsecond after this is the main explosion. You get the ejecta coming out and the melt, of course. And then, of course, you get the transition. So you're looking at from a microsecond to a couple of minutes after the impact. This is what it kind of looks like. Impact melt and ejecta flying all over the place. And then we have what's called the crater that we look at before it starts getting eroded. And a couple of points I want you to kind of remember here. One is the impact melt inside the crater and the fractured rock. The fractured rock, if you look at it, it's like a bowl shape. And how a bowl shape of fractured rock would happen is fairly, the only geologic function we can actually find out how this happened is from an impact. And you're looking at, as I say, when the bolide goes from 14 kilometers a second down to 0, you're looking at a lot of energy being dispersed. All of a sudden, from 14 kilometers to 0, that energy has to go somewhere. This is the explosion that causes the circular craters. So, now you're experts in craters. Let's get on to how Brent was actually defined as an impact crater. Well, this started off actually at World War II. This circular function up in the upper Ngava was used as a navigation mode as the guys were flying across the Atlantic. This is probably the last sure fix they got on North America before they hit Greenland, Iceland, and maybe if they're lucky, hit the UK. So Dr. Amin at the Royal Ontario Museum was thinking of, well, let's go up there and take a look at this thing. And there was this guy named Chubb. He thought this was a kimberlite, and he was going to be rich because the kimberlite was just an output of diamonds from the interior. So they went up there, and through various, I should say, expeditions, not the first one, maybe the third or fourth, they finally found sure proof of this, why this was an impact crater. The implication was, yes, it is an impact, but the firm proof took a long time. But from the fact that the New Quebec crater, you look at it, the size of it, whoops, I'll go back here. There we go. The size of it is pretty small relative to all the other guys that we were found here in Canada. But from the New Quebec, the Pingulet, or the old Chubb crater, that was the three names over the evolution of the crater exploration. All these other craters were sort of, well, let's go look at these circular functions to see if they are in fact impact craters. And the ones that are shown here, this is from an RASC journal from long ago. These are in fact impacts. Now, look at the right-hand image there. You see the New Quebec and the Brent crater are almost the same size. And aerial high altitude images of them, pretty well defined. Yes, they are pretty well exact. So is Brent, that circular lake that we see, is it a crater? Well, I don't know. Let's find out. So being an explorer, of course, I had this airplane. I was very fortunate to have this airplane for a few years. And I actually flew over the Chubb crater, the Pingulet crater, years and years ago. And this, of course, was, to me, a dream of a lifetime. Because I remember there was an old CBC show back in the 1950s where Dr. Amin was documenting his expedition up to the Chubb crater. And, you know, I was only about this high. And I says to Dad, Dad, can we drive up there and see it? But I don't think so. It was quite the expedition. Anyway, it took them, I think they had a Canso that flew into the lake in the background there. That lake was called Museum Lake. I think they've changed it, but they landed there and then explored the crater from that. So, is a circular lake proof of an impact? Well, maybe, maybe not. Let's find out. Oh, I'll go to the crater rims first. The image on the left there is the Chubb crater. I actually walked around it. That was a cool expedition. And this on the right is the Brent crater from us doing our expedition. So these are images of the crater walls of each crater. And if you look on the image of Pingulet on the left, just imagine Brent looked like that less than 1 million years after the impact. So that's what Brent looked like back then, 300 million years ago. So it gives you an idea of how big this crater really was. Okay, so circular lakes. Let's find out if they're craters. Well, there were a lot of circular lakes that weren't. Can you see which one is and which one isn't? I would say the one on the right's Brent crater. Oh, I'm right. Yeah, so just wanted to give you an example. If you look on my website, I have a few other examples of lakes that look almost exactly like the crater that we showed. And nope, there has to be some geologic exploration of proof of how it's a crater. Well, what kind of geologic expedition should we do? Well, first of all, let's prove that, in fact, it looks like a crater, and yes, it does. The image on the right there is just an altitude depiction of the Brent crater. Shows you, yes, it is fairly circular. So, Pingulet, this is the Chubb crater up north. This was impact melt that we found up there. My buddy Eric found this piece on the left, and I found this big chunk on the right. These were the impact melts that were proof of impact at the Chubb Pingulet crater. So, do we have similar proof here at Brent? And yes, we do. We actually had to drill to get it, but there is a melt zone down 850 meters deep. The bedrock, unfractured bedrock, is almost 1 kilometer deep under the Brent crater. So it just shows you how deep that bowl was. But a couple of points I want you to look at, to remember. One is, of course, the impact melt. That was the proof of impact. But the bowl shape of the fractured rock, this is what was the purpose of our expedition coming up. So you're looking at almost 1 kilometer deep. Oh yeah, Tecumseh and Gilmore Lake. These are two lakes in Brent, in Algonquin Park. I'll go back here. Yeah. These two lakes, they are very unique in Algonquin Park. The pH level of these guys are totally different. And the reason for it is that there's a layer of limestone that was deposited long after the impact. And that limestone is actually the floor of these lakes, which causes the pH of these lakes to be kind of crazy. And no other freshwater lake in Algonquin Park is like that. And why is there limestone in the bottom of that crater? Well, it was a bowl, and it got filled with limestone. Then as the glaciers came back and scraped all the limestone off the bedrock around Algonquin Park there, the part inside the Brent crater was left or attenuated just a bit. And so the limestone was left inside the crater, which causes those lakes to have that crazy pH. So, oops, I'm going the wrong way here. Good thing I didn't do that in the airplane. There we go. Okay, so we found out, yes, it is an impact. We found it because of the impact melt and the fractured rock and so on. But how did we find out that it was 396 million years old? Well, this is kind of interesting. There's a thing called the, had a brain melt there for a second. The potassium-argon ratios. Now, potassium is in bananas. It's kind of radioactive. It does decay, and it does decay to argon. So before the impact, the little part on the left there, before the impact, there was potassium and argon in the bedrocks, and everybody was happy. Then all of a sudden, this boilite came in and schmuck at over 14 kilometers a second and totally melted the area. So what happened is that the potassium stayed in, but the argon all vanished. It just exploded out of the melt rock. So then what we have is a fresh clock. The stopwatch starts, and then as the rock hardens, the potassium again decays into argon and other things, And the potassium-argon ratios gives you the exact age of these craters. So that was a kind of a fascinating thing. And a lot of the dating of craters in Canada are from this. There's other methods, of course, but this was one of the main ones. So this is how Brent was dated at 396 million years ago. Just trilobites coming around. So this is, again, on the left is the high altitude image, and on the right are all the drills that the government did, Geologic Survey of Canada, to prove what is down there, and gave us actually the profile of the crater. So just to, I mentioned at the beginning the slide where we showed the central dome there, the central dome right there. That is just covered by glacial till, basically. So the limestone is underneath. There's a layer of limestone, and then, of course, the fractured rock, the bedrock, and so on. So the pink is the Precambrian rock that's pretty well scraped clear of limestone from the glaciers. Then the glacial till left over from the limestone that's left around. And, of course, the blue limestone area, that, again, is like a bowl. The blue limestone, oops, let's go back here. The blue limestone, oh, wrong button, there we go. That there is what's underneath the lakes. It causes the pH level of those lakes to go kind of wonky. So, expeditions. As I mentioned, I've been doing this for 30 years. Brent was my first crater. In other words, that was my first. Yay! So, number one, I just showed you, look at that dome there. If we walked into that dome, I bet you we'd have a fabulous view of that crater. Well, oh yeah. So actually, I'll go through the what we did here. Number one, that was our dome. We went there just to actually see what a good view of the crater, because we're right in the bottom of it. We had two other expeditions. One was looking for breccia. We looked all the way around the crater rim for breccia. We couldn't find it. Number three, Eric Kujala, my other crater buddy, he and I took the canoe, and the launch port was here. We had to carry it down from the road. It was over here. Carry it through the bush. That's a lot of fun. We launched the lake into that lake here, portage there, and then just explored both lakes looking for breccia. And then, of course, number four with Paul. Paul, at a RASC supper 2 years ago now, cornered me and said, "Chuck, that mini Grand Canyon you discovered, we got to go find it." I said, "Yeah, okay, what the heck? Let's do it." So number four there is our expedition. So we went to show you, we went from the road. There was a trail down here. Paul has some examples of the rock at the south rim. This is the south rim here. And then we trudged through the bush, and we found, after 20 years, my 20-year absence, we found the mini Grand Canyon and trudged through the bush all the way back. That was fun. Thank you, Chris, for that GPS. Sarcasm. Anyway, so that was my 4 expeditions, plus there was a lot of aerial explorations of it as well, but you could see I had a lot of fun. So number one, here I am at the central dome. Look at the view that we had of the crater in there. Look at that. We could see what, 10 feet. Anyway, we got to the dome anyway. We found it. That was kind of cool. So the second expedition, I was going around the crater rim looking for breccia, and I found this thing, the one on the image on the right. That was my mini Grand Canyon that I posted on the web, and then kind of forgot about it until Paul cornered me and said, "Okay, let's go find it." But we trudged through it, and I looked at it, and I said, "Well, that's cool." And then no breccia, we just carried on. I didn't spend too much time there, unfortunately. So that's what it looked like 20 years ago. And of course, expedition number 3 with Eric and I, we went through the canoe and around the various lakes. And this is Gilmore Lake, kind of a cool little freshwater lake. And this is me on my 4th expedition on my 79th birthday. Wow. I can still do it. So, this is our crew: Chris, Louisa, Jillian, me, Paul, and Andrew, you here tonight? Oh, rock and roll. Oh, yeah. So I just want to point out, if you ever drive from here to North Bay, I want you to look very closely at the rock cuts, because as we get closer and closer to Brent, you'll find this fractured rock syndrome. So you're looking at, a rock, as you see here, 100 kilometers from Brent, pretty solid. You're getting closer to Brent, and it's pretty well whacked to heck here from the explosion. So just about any in situ rock around the Brent crater is kind of shattered like that. I found similar situations when I was going to Manicouagan from the St. Lawrence River north. As we're going through the various rock cuts, the rocks get more and more shattered until we actually get to the crater, and they're almost pulverized. It's kind of cool to document. So what you want to pay attention to now is the fractured rock zone. This is the bowl. You look at it. This is the bowl where the fractured rock is actually enclosing the crater. And these are the fractured rock on the outside of it. And this is Paul. Thank you very much for this illustration. This is our expedition to find it. And we did find it. Paul got some rock samples here. We stopped here and got a lot of good rock samples. This is the portage for the canoe, and we went through Tecumseh Lake to the other lake there. And of course, we trudged through the bush and finally found my old Grand Canyon after 20 years. It was kind of nice to see the old guy again. So here it is. Now you have to picture this. This is a rim of a bowl. This bowl, I'm looking from the inside of the bowl. This is the rim at the lip of the bowl, and it goes completely around the crater. So this is the shattered rock, a fractured rock that was sort of eaten through by this creek. So you have to imagine this is a fairly substantial creek because there's a lake behind it. See if I go, yeah. No, yes, here it is. So this lake here flows into the crater, and it goes through the fractured rock here. So you can imagine that fractured rock zone, that wall there, was kind of like a dam. And every once in a while it would fill up and then burst and fill up and burst until what you got is this canyon here. And it's kind of a unique little geological specimen. It's nice to see it after 20 years. So one of the points I wanted to mention earlier, and I forgot, was that impact melt, planar deformation features, shattered rock, of course, and shatter cones. These are things, and breccia. These are the main things you have to look for if you see a circular lake. If you find yourself in the bush and you see a circular lake with a shatter cone on it, you're going to be famous because they'll have the crater named after you. And I'll show you. I have a definite or an example of a shatter cone. We'll show at the break here, and everybody can look at it and study what it looks like. So when you go in the bush, you have to promise me you'll look for shatter cones. But anyway, this is the internal portion of the picture on the right is the internal fractured rock wall that we went through. And I looked at it very, very carefully. I could not see any shatter cone effect. It would have been cool if I did, because I would have been the only one that was found there, but I really looked hard to see any, and I didn't. The image on the left, that is again, in situ rock on the south rim of the crater. So I assume that it was the glaciers that removed all the fractured rock around that. And it might have some, how should I say, impact feature compression of the bedrock there. And Paul has a sample of it here that's kind of, it's a different looking bedrock, I'll put it that way. But looking at this fractured rock zone, so I showed you the earlier picture along the highway of the fractured rock. Well, this is right in the crater. This is fractured rock inside the crater. And this is a bowl that goes right down underneath, a kilometer down and back up the other side. That's kind of cool. So this is, give you an example of the scale of it. Jillian, Andrew, and yours truly sitting in there. And here I am, 20 years after finding it, and was kind of a fluke of me finding it the first time. And that was a, how should I say, a neat expedition. This is looking look inside the canyon, looking up the crater rim. And this is Chris and Louisa climbing up the rim. That's kind of the same scale as the Chubb crater I showed you earlier. So you're looking at the crater rim there. And looking back from the crater rim down into the little crater, and that's Paul way over there getting his last rock sample. He was the guy that had the most rocks. I give you the credit, Paul. Yeah. Now I'm a rock hound, but Paul beat me on this one. That was kind of cool.
Glad I had a big backpack.
Yeah. So this is kind of the circle on the right of this image. That's kind of where the mini Grand Canyon is. If you look kind of in the front there, you can almost see the crater rim effect. The crater rim going around here, and the rock wall is just internal of the crater rim. It's kind of a neat effect. And the circle in the foreground is the lookout. And if you're on the ground, the best lookout is from the lookout. So this is Eric and I. Eric and I went up to the Chubb crater. We actually walked around it. And I dragged Eric to a few craters. And this is our example of flying around the Brent crater. Let's see if it works. Here we go, Chris. Whoop, was this it? There we go.
Then they have to use a telephoto. You don't need a telephoto.
No. Wow, that's going to be really good for the presentation.
That's the dome there.
It shows the perspective with the river there, the lake.
The crater rim. Whoops, sorry. Whoop, I'm sorry, Chris. That's my fault. The crater rim.
Then they have to use a telephoto. You don't need a telephoto.
No. Wow, that's going to be really good for the presentation. It shows the perspective with the river there, the lake. Wow.
Perfect. Stop her there.
Now the rim is about here, eh?
Perfect. Yes. Okay. I want to stop it there just to show you. The mini Grand Canyon is right about there. The lookout is right about there. And the trail going down into the crater on the south rim is right there. So Eric and I, we took the canoe, portage, walked around and back, and we did, in fact, find the breccia. Okay, let her up, Chris. Thanks.
Yep, that's right.
And that's snow in the background, by the way.
The whole thing in the shot.
We got the whole crater now, yes.
That's snow in the background, and it's August. Here's the portage. So you have to be fairly fit to be falling stuff all over the place. Just imagine limestone all the way underneath these guys. And of course, the great view from that little dome there.
So what I'll do, I'll just do some lazy circles as we climb, okay?
Okay.
Yep, that's right. I'll go down that way.
Was that supposed to be an erratic?
Probably, I'm sure it was. Sure it was an erratic.
So the erratic that Eric was talking about.
Then they have to use a telephone.
There we go. The Eric, it was a piece of breccia we found. Now this is not in situ breccia, but kind of an erratic within the crater of, I'm pretty sure it's impact breccia, but it might, well, I can't 100% be sure that it's from Brent, and I can't do the chemical analysis of it. But it is, I'll get the definition here. So it's called melt-bearing mixed breccia. And you see the rocks within the black melt there. The rocks are all shattered. They're not fine like a conglomerate rock. It's all smooth because it's been eroded through rivers and so on. But this is bedrock that's been shattered by the impact and then dropped into the impact melt. For scale, that's my geological hammer there. So yes, we did find breccia finally. So I can rest easy now. So I mentioned shatter cones. In Sudbury, there's wall-to-wall shatter cones. If you ever get up to the Sudbury impact crater, look at my website first to find out where you want to look at. But these are awesome examples that we found. Jillian and I just randomly found this by driving around, and it was really cool. This here is a shatter cone effect from an impact. So there's two functions that would cause a shatter cone in a bedrock. One was a nuclear explosion or a bolide impact, and Sudbury had a substantial one there for sure. And just south here, about 2 hours south of Ottawa, is the Holliford crater. And this is an image we took of the tour I led through the crater back in the GA back in 2017. We had a lot of fun that day. It was great. And the people that owned the lot that we're on allowed us to park the bus right there. And he actually has a golf tee. He can actually bounce golf balls into the hole, get a hole in one easy. And a bit of humor. As I mentioned, my airplane. This is the Nirvana airport. It's long since been demobilized. But of course, it's a very light, quiet zone. So our guys do a lot of expeditions there. It's kind of cool. So somebody drew a picture of me trying to do a touch and go with all these guys with telescopes on the thing. Kind of neat. GOZM, that was my airplane. Had a lot of fun. So, just to conclude, Isaac Asimov has a good quote. He says, how bright and beautiful a comet is as it flies past our planet, providing it does fly past it. Yeah, that's Isaac Asimov. I love it. Anyway, thank you very much. That was good. I had a lot of fun. Any comments, questions? Did we get it? Yep, go ahead. I'll repeat it. Okay, yeah. The scale? Okay, if you look at the crater, it's a 6-kilometer walk around the crater rim. Actually, 6 miles, 10 kilometers. So the scale, actually, let's go right back to the beginning. Can you go right to the beginning, Chris?
Yes, you can.
Yeah, I can. Let's do it then. I'll just go back and I'll give you a good example of the scale. Because the scale of Brent is exactly the same as the Chubb. Here we go. So that's the scale there. So you're looking at the rim. That's the same size as the Brent. And you're looking at almost a 10-mile walk around it. So gives you, this is a person walking way in the distance there. I was the last guy hiking around the crater there. I don't know why I was last, but yeah. So this gives you the scale of how big that thing is. So it's big. Yep. Right there.
Do we know how many craters in Canada that are from impacts?
30-ish. Let's find out. Whoops, let's go back. This was from the RASC Journal in the early 1960s. So you're looking at, almost 20 there, and it's around that figure, 20, 30. But most of them are in the Quebec bedrock. There are a lot in the prairies, but they found by drilling for oil, and they found the magnetic signatures by finding something strange while they're drilling. And of course, when they drilled far enough, they did get impact meltdown there. We have another one there.
Why is it that the Pinglet is like an open lake, whereas Brent is mostly filled in with sediment?
Yeah, I would say because it's 300 million years older. And as I say, the glaciers came by, there's a couple of kilometers thick glaciers that scraped off the limestone and pretty well filled in the crater. So It was a substantial hole in the ground at the time, so when the glaciers did finally melt, there was a little indentation in the ground. So Brent was not a good crater, like it's an old crater, but it's pretty well filled in from glacial till. One of the images I showed you was all the glacial till that actually filled the crater. How are we doing? Okay? Okay, thank you very much. That was great.
Thanks, Chuck. Just a quick follow-up on that last question. As Chuck mentioned, the Brent crater is on the order of 400 million years old. The Chubb crater is believed to have formed only 1.5 million years ago. So it's quite young in comparison and hasn't had all that erosional effect. The Brent crater had multiple episodes of glaciation over the 400 million years, whereas the Pingula crater formed basically at the end or at sort of the petering off period of just the last glacier 1.5 million years ago. So it's pretty fresh looking. If it wasn't for the infill from the melting glaciers, I think it would look very much like the Arizona meteor crater, if you've ever seen pictures of that, where that wasn't filled in. It's only about 50,000 years old or so, and it's quite a distinctive depression. But yeah, that's the main reason it looks a little fresher. The other thing that Chuck didn't mention was the hike that we took. There is a trail up there because it's a recognized site, and the trail that's been carved out, for people to explore, I think is on the order of 1.5 kilometers. It's a sort of a loop trail from the observation tower on the highway. To find Chuck's Canyon, we had to do a little detour. So our expedition was about 6.5 kilometers long, 4 of which was through bush, which I really regret. I remember asking Chuck, I brought a machete. Do you think I will need it? He said, nah, probably not. And I left it in the car.
Should have brought it.
Damn you, Chuck.
I just want to say a couple more things.
Absolutely.
I forgot to mention, this is Comet Cahutek taken by Peter Saravallo and processed by Deborah. So they did a great job on that.
Thank you. So just to close off on that, I really want to thank Chuck and Chris for the work that they put into helping organize that trip and leading us in and back out safely. If you looked carefully at the trail map that I had given to Chuck there, you'll notice a few zigzag patterns in our path, because at some point we were not quite sure exactly where we were. So thank you, Chris and Chuck, and thank you for Garmin for the GPS watch that Chris helped get us out of there. A wonderful expedition. I definitely would go back. Super. All right. Oh, and we do have some samples. Chuck mentioned that he brought a couple. I also brought a sample from the fractured rock that Chuck mentioned there, which is exposed on the known trail. It's one of it's post 7 on that trail, and we also collected samples during our off-trail expedition, including at Chuck's mini Grand Canyon. So you're welcome to come up and handle this if you want. Basically, what this is a piece of the original bedrock that was modified by the enormous energy of the impact. 250 megatons. They say that if that happened now, every tree in Algonquin Park would have been burned, and every window in Ottawa would have been shattered if it happened now. So interesting piece. It's very heavy. It's microcline gneiss rock, and it's suffered a little bit of fracturing. So you're welcome to come up and handle a piece of history from 400 million years ago. All right. We'll just go through a few notes here, and then we'll take our break. Benefits of membership in our club is interesting talks like the one that we just heard, and a chance to meet and talk with people that have a like interest in astronomy and other things celestial. We also have Ted Bean Loan Library, where we can lend out telescopes to new members. I've had a couple of emails on that, wondering about how that operates. So yes, feel free to contact Peter Shute if you're interested in perhaps borrowing a telescope. Certainly a good idea to try before you buy, because good telescopes don't come cheap. We also have our loan library. Unfortunately, Estelle has decided to hang up her librarian hat, and so we're looking for a new librarian. If anybody's interested and is a lover of books, we have an extensive library of astronomical books that we lend out to our members. All right, oops, shot past one there. We also, as part of your membership, you get the Observer's Handbook, which is a super wonderful guide on everything happening in astronomy, including monthly lists of things that are to look for in the sky, and just amazing articles on technical stuff, such as actually Jim Thompson did the piece in the Observer's Handbook on filters. And a very good piece of work there, but a lot of technical stuff as well on the planets there. So a wonderful guidebook that's been published for, I believe, about 60 or 70 years annually. You also have access to the journal, and which is again a technical publication of the RASC. And you get our wonderful astronotes compiled by Doug Fleming and Gordon Webster on the monthly occurrences at our meetings. You're also eligible to log into the Discord server, which we have, which is a members only communication forum for us. And you're eligible to get a copy of Astrospheric Pro, which is a wonderful application in terms of weather predictions, and similar to the Clear Sky chart, but more elaborate with different models and such shown on there. We have access to the Pro Edition, which is normally $66 a year, but it's part of your membership, so you get it for free. And so our membership fees are $110, $118 for a regular membership, $112.50 for a family membership, plus $18 for an additional adult, and $10.50, excuse me, for an additional youth. And we have a youth membership for students under 21 at a discounted price. All right. At this point, we'll take our break, come up and handle a piece of history if you'd like. Just a reminder that the rest of the museum is closed to us, so the foyer is open, obviously, in the washrooms, and enjoy your break, and we'll be back in, we're doing pretty good for time there, so get a chance to talk to folks, and we'll resume in 15 minutes. Thank you. Yeah. So this is a piece of when Chuck showed the bowl-shaped depression. This is a piece that's believed to have been on the rim of the crater after it got blasted out, and over time, through erosion and glaciation and such, this is from a slope, an outcrop, that one of the few outcrops that's visible on the site. Believed to have landslided down from the rim, and that's why it's exposed to us. Very cool. This is a piece. Yeah, it's essentially a piece of the original Precambrian rock that the meteorite actually blasted into.
Totally shifting gears. I sent you an email a couple of days ago for a idea for a presentation.
Yes.
For the Starfront thing.
I haven't answered you on that,
All good.
but yeah, I'm definitely interested in that. So where did you send your telescope?
It's in Texas.
It's in Texas.
It's
Okay.
Starfront, and they got 300 clear nights a year, which is
More than we got.
more than we got.
A lot more than we got.
It's pretty awesome.
Yeah, definitely.
So I've been using it, and I just wanted to go through the whole journey and
Yeah.
just
So it's
how you-
fully operational?
operational. You just click a button and you connect to your computer down there, and
That's pretty wild.
portal one skies, and
Yeah, pretty nice. Charge for something like that.
it's dependent on your scope size.
Okay.
So for our scope, it is 200 US, so 280 Canadian.
Yeah,
Um,
not too bad.
not
No,
reasonable.
it's
I'm
not
splitting it with someone, so
Yeah.
we're sharing the cost, so that makes it. more
Have
good.
access to those guys, and do they do the maintenance and stuff like that on?
We
If it
have,
needs it?
if it needs it, that's extra. but you can also have them like troubleshoot things. So like if your camera starts like hiccuping or like you need to replug something in or whatever, they're there to try things for you. So
Right.
it's a pretty cool service.
Excellent.
Yeah.
Well, I'd be very keen on hearing that and seeing some of the results, and certainly under those conditions,
It's pretty good.
the clear skies. I mean, like November and December with the jet stream that we have, it's just been dismal.
Totally. Yeah.
It's like, I think in those 2 months, I'm used to going out usually a couple of times a week if it's clear, right?
Mhm.
And do maybe, 80 to 100 sessions a year there. But I think in November, December, I think I had a total of about 6 or 7.
Yeah.
And even those were kind of marginal.
Yep. I know what you mean.
So that
Yes. Yeah.
definitely would be interested in that.
Yep. Awesome. You said like April, May timeline?
Yeah, so I'm booked basically now until about, I think I'm waiting on 2 confirmations, but I'm booked now until the end of April.
Yeah.
So if you want, I can put you in for May.
Sounds good.
Yeah,
Good.
okay, I'll reserve you a slot.
Sounds good.
Consider it done.
I think it's cheaper than the
This is me.
property taxes on my cottage.
Fantastic.
Probably.
One down, one last one to go. And I don't see him in the room here.
John or
Yeah,
Jim?
I'm sorry,
Is that
John.
you sure?
John, oh yeah.
John?
Yeah, Jim's right there. He has his. Thank you. Easily mix
Oh,
those
the
two up.
fees themselves.
They're totally different.
Those are, Chris.
Yeah.
Are those the old fees?
Are those the fee numbers or are the current fee numbers on that?
Oh, okay.
I think
I,
they're current.
recently.
Yeah.
Okay, all
I thought
right,
you
I couldn't
did,
remember,
yeah.
Yeah,
Good.
good.
I remember explicitly updating them when we changed our fees.
Yeah.
And I
Right.
went on the national site, confirmed it was there, made sure so
Yeah.
there shouldn't have been a change since.
Okay, yeah, I just couldn't remember what the number is.
Yeah.
All I know is in the first, 3 months of the new fiscal year, we're doing not too bad.
What's always so misleading about the slide that we thank the 100 and so new members, we lose the identical number, so our membership is flat, kind of flat. Every year.
Yeah.
Well, last year, that's probably unusually high, 125.
Yeah.
But we're still in the same rough number.
And we need to ponder why we're, if we even kept 10% of something.
Yeah, I think so.
We-
Yeah, certainly some people, they join, they try, and if they don't find what they like, then they move on. This is why we do things like the surveys and that, but, we're contemplating moving our site here as well to another venue that might be more convenient for more people. So we just want to get that feedback so that we can try to tweak things and make it as enjoyable for folks as possible.
I'm in Lindley, and it's not more, nothing else would be as convenient as this is. for
For you, this,
Yeah, I'm about 90 kilometers away.
I'm ready to show people the Grand Canyon again. Finding it this time would be trivial.
Yeah, don't lose that watch. I want to get
It's
one.
not the watch, it's
Yeah.
it's the knowledge where it is and what's wrong with all the maps.
Yeah.
It would be a trivial thing to find.
Yeah.
Yeah, having real GPS coordinates also helps.
Yeah, and
You can
nails
just, you
down,
can turn a blind eye to every your surroundings, you just go for that.
just go for that.
This is the this is the
So-
laser.
so-
huh? Is that the laser?
Yes,
Yeah.
not to be confused with advancing.
I see.
What Chuck kept doing, hitting that for the green light.
Gotcha.
Have you had training in the use of the laser, though?
How are you? They did the walking paths between the observatories at the Lowell Observatory. Oh my God. They're like, that's resistant to the material lines. Oh, wow. To keep people from falling and wandering off the trail. Yeah, it's just great. And, where was he buried? You have a mausoleum, he's buried right there. Who is buried? Percival Lowell.
Oh, there.
Oh, on site.
Yeah. So
Did you get to recognize it in chat the way to Rome? One of our past meetings here? Hasn't been here in.
Because he moved up to the Yukon or something.
No, Callaway. He's been a crown prosecutor in Callaway, right?
I've got my calendar. Good.
There it is.
It's 20.
$20, yep.
I was singing Messiah that night. That there's a sing-along Messiah.
The last one.
Yeah, there's a sing-along Messiah that I was doing that night of the meeting, so.
Thank you. I'll either give that to Cliff or I'll do an e-transfer to
Mhm.
him.
Oh, that's a, I know what you mean. It's sort of an impact melt that was going out and the landstone. They are difficult. You can find this. There are, there's all kinds of black and green and clear. It's, one in Africa. Yeah. Yeah. It's almost. My website was,
You in for no? It was, some of those trees were. Fortunately, they were mostly dry, so that's kind of, yeah. That was awesome. Couple of minutes, yeah.
Yeah.
I love it. I think it's just awesome. I know.
Oh, there it is.
Happy New Year again. I'd go again. Yeah. Yeah. First time I went there, it's like, and you ran into it. Awesome. No, that's one I just recovered there, but it was from the first, one that actually on the official trail. Yeah. But yeah, here's what I can say. I didn't bring. But it's I've seen some of the micro photographs that I. Yeah, there's some interesting stuff. Good.
You picked that up and you smashed it off the wall. Yeah. So it hasn't been impacted by the weather as much.
Animals on the ocean.
Yeah.
It was.
Well, that's the thing, yeah.
Well, not to be Chris, just.
I'd go. I haven't been to Algonquin Park since I was in high school. Went camping there.
Yeah, that's right too. You know, I scoured my pictures Especially the ones where you want to do that. To see if they, if I can find them for you, but.
Yeah, you were looking for your glasses. In the crater somewhere. In the canyon. Yeah.
But the canyon was a little bit else, there, especially up close to it. Was, yeah, even from that different, from the outside, but that's actually, you and I were up on that, above. Did he? Yeah. This was from this. It was part of our trip there. It was on. It was actually from the rock out products like that's the first one that we got to. Yeah. It is. Yeah, it really does. Yeah. Well, it was a hard slog at times there. That was interesting. Don't drop it on your toast. Guaranteed to break your toast. All right, folks, if I can get you to take your seats, we're going to resume with our meeting. And I just had whispers in my ear from Chuck and Chris saying that they'd be interested in going back to the Brent. So we did announce this expedition, which occurred in May of last year. We did announce it, I think, a couple of months before we actually took part, because we had to wait for the weather and for them to open up the road. And we will do that again if there's enough interest there, and we can mount another expedition. If you're into hiking into a blasted out meteor crater, I'd certainly be up for it myself again. It'd be my third shot into it. So awesome. Okay, well, I'll keep that in mind, and maybe we can do something again for spring. May was a beautiful time to go because it was before the bugs came out, and they can be pretty brutal up there. And it was also interesting because a lot of the trees weren't sprouting their foliage yet there, so we actually got some much clearer views through the bush than you would in the middle of the summer. So and no mosquitoes. That no black flies, no mosquitoes. It was actually we aced it. We got a beautiful clear sky that day, all day. It was reasonably warm, and there were no bugs there. So it was. I don't think we could have pinned that any better. And it was your birthday, so good birthday present to rediscover your mystery canyon. All right. So I will keep that in mind, and we'll see what happens. Maybe we can. Maybe we'll do a bit more talking amongst this and see if we can organize something again for the early spring there, or the mid spring. Okay. There we go. All right, kick off our second section. We have an Astrobit segment, and we're gonna have. Where are you there? There you are. We're gonna have a look at some pretty cool solar stuff. There you go, sir.
Oh, greetings, everyone. Let's see now. A while back, I was showing some of my solar animations to Simon Hamner, and he said about one of them, That's coronal rain. And I thought, that's interesting. I've never heard that term before. So I decided to do some reading about it and search the net for images of this phenomenon, along with my own animations, and to share that information with you tonight. The first one comes from an image taken by NASA's Interface Region Imaging Spectrograph, or IRIS, a fitting acronym for such an instrument. Notice the scale of this solar activity in comparison to the size of the Earth in the lower right-hand corner. The second image looks more familiar, coming from the Solar Dynamics Observatory, showing the downpour of plasma initiated by two disruptive events, a solar flare and a coronal mass ejection. But what specifically is coronal rain and how does it form? Well, I'm not an expert in this area, but here is what I've learned thus far. Coronal rain is the sun's version of precipitation. Usually, following a solar flare, or a coronal loop, or a coronal mass ejection, or any ejection of plasma energy, the hot plasma, high in the corona, cools and condenses dramatically into much cooler, denser clumps, temperature being approximately 10,000 Kelvin. And this plasma descends toward the photosphere, which is the visual surface of the sun, in the path of magnetic field lines. Now, the cooling causes thermal instability, where localized regions lose heat faster, leading to a condensation of plasma into dense clumps. Coronal rain can take the shape of small loops or massive arches. It can also look like streams or droplets of glowing plasma cascading downward, which you will soon see in action in a couple of seconds. So to briefly summarize before we see this, coronal rain is a solar phenomenon whereby hot plasma in the sun's corona rapidly cools, condenses, and falls back toward the surface along magnetic field lines. Coronal rain plasma reportedly falls at speeds on average between 50 and 100 kilometers a second. Here we see coronal rain in the center of the image. That would be about here, and it doesn't show up as well as it does on my computer, but you might see it right there. And okay, so where am I? So we're looking at coronal rain, but I also want to mention that it was a very active sun that day. But in terms of the coronal rain, what it looks like in this particular image is streams of plasma that's falling towards the surface. But you may also notice the huge active region, which is the dark patch. Now, you won't see it over here. There's a dark patch right over there. And that dark patch signifies a very active region. The darkness, because it's an inverted image, it shows a couple of sunspots as well as plages, which indicate very high magnetic activity. And you'll also notice some prominences along here And you might also be able to see, well, we don't call them prominences on the surface, they're called filaments. But those are actually prominences that would be if they were on the plasma, if they were on the limb. And here are some more. So that was an active sun that particular day. Oh, here we go again. This is my wild image. Okay, so what you, oops, let's go back. So what you see, unfortunately, the speed here is quite fast. But you see the coronal rain that's occurring right over here. And you might even see the coronal loop right over there. So in this particular image, what we're looking at is coronal rain in the shape of massive arches. Unfortunately, the speed is a bit too fast. But you can imagine how huge these arches are, considering the previous Earth to Sun size comparisons. Now, the benefits to understanding coronal rain have been reported. Studying coronal rain through what is called magnetic field mapping helps us understand how plasma or rain traces magnetic loops, revealing solar magnetic structures. And understanding coronal rain formation can also improve our models of solar flares and coronal mass ejections. Thank you.
Thanks, Jim, and as usual, wonderful imagery. That's amazing stuff. Very cool. All right, next up, we have Jonathan giving us his first chapter of the Frontiers of Astronomy, Astronomy 101. Take it away, Jonathan.
Thank you very much, Paul. I hope everyone can bear with me. I'm getting over a case of laryngitis, so if I lose my voice halfway through and start croaking away, please be kind to me. That was an excellent presentation on coronal rain. I'm just wondering what kind of umbrella you're going to need for that kind of stuff, but
Big one.
a big one. Anyhow, so tonight I'm going to talk about the basics of astronomy. And I know some of our presentations tend to get a little technical, like viewing the planet Cousbane by putting an unobtainium filter on our telescope. We can see it 3 galaxies over. So for some of our newer members, we're going to spend some time tonight on basically the basics, and then we'll take it from there. Okay, so Frontiers for Beginners, Astronomy 101. Tonight, I'm going to talk about how to get familiar with the night sky, what you might want to look at in a telescope, what kind of reference material would be really handy, and in this day of technology, what kind of applications you might want to look at on your computer or your phone. So let's start with the night sky. I'm going to go over some very common constellations, and if you can get these half dozen sorted out, you're really going to understand the North sky. So let's start with the Big Dipper. And yes, it looks like that. And I think everyone probably stands a pretty good chance of finding the Big Dipper in the North sky, because probably mom or dad has shown them at some point in time. But it's a very important constellation because it's where you start to find a bunch of other stuff. From the Big Dipper, you take the 2 stars at the front end of the pot, and you just take your finger and you go up, and you're going to find a bright star up in the sky called Polaris. And this is a very important star because this star lines up with the axis of the planet Earth. And so over the course of the night, the whole sky rotates around Polaris, but Polaris doesn't move. And this is going to be important later on. We'll talk about that. And from Polaris, you see the Little Dipper. And I have to tell you that unless your eyes are really good and it's really dark, Polaris is bright. The 2 stars at the far end of the pot are bright. The stars in between on the Little Dipper are really dim, so it can be a little bit hard to see. But from those 2, you can start to get a feel for the sky. And of course, where Polaris is, which we're going to talk about a little bit more in a minute. From there, and again, the sky rotates, so the Big Dipper might be up there. You find the North Star, Polaris, and you go a bit off to the right, you get this funny W called Cassiopeia. Now, I call it Cassiopeia. Now, some people are going to say, Jonathan, it's Cassiopeia. But I grew up on the wrong side of the track, so I call it Cassiopeia. And we're not going to get into how you pronounce that planet between Saturn and Neptune, okay? So, because that's another controversial one. Cassiopeia is an important constellation too, because it helps you to find the easiest galaxy to see, the Andromeda Galaxy. So once you find Cassiopeia, you take the pointer on the right side of the W, and it's going to point to this smudge you see in the sky. And you can see on a dark night this smudge with your bare eyes. And that's the Andromeda Galaxy. Right above the constellation of Andromeda and square Pegasus. Ignore Jupiter, it just slid in here on this slide. It's not always there, it moves around a bit, okay? And Andromeda is a really cool thing to see. It's easy to see with some very basic equipment and actually get to see your first galaxy, which is really cool. All right, and the other constellation I want to talk about is Orion. And I'll talk about in a little bit how you kind of find Orion. But Orion's fairly easy to find because of those 3 bright stars in the belt. And they have names. Don't ask me to remember what the names are. But there are people in the audience who know the names if you really want to know the names. But Orion's a really cool constellation to find because in the neighborhood is all sorts of stuff astronomy-wise as you get into looking into stuff deeper, that's really cool that are in and around the Orion constellation, okay? All right. So let's talk about the moon, because the moon is something that we can pretty well find without much problem. But the moon is an interesting thing, and I'm going to do a whole separate presentation on the moon at some point. But here I wanted to show you 3 graphics. The first is on the left, the harvest moon, the bright yellow. And we've all seen the harvest moon in the fall, and we had the wolf moon, I believe. It's called. Yep. We get them throughout the year, and you get a very great view of the moon when it's full. But you also get a really great view of the moon when it's half lit. And what you can see from this picture is pretty obvious right away is with the sun grazing across the moon, you really start to see the craters and the canyons. And whether you're using a basic telescope or not, you can really have some fun just exploring all that. And of course, at the bottom right, you're seeing a lunar eclipse, and those happen a lot more than solar eclipses. And they're perfectly safe to look at, unlike a solar eclipse where you have to do all sorts of funky stuff so you don't burn your retinas out. And seeing a lunar eclipse is really quite something to see how it goes so orangey copper comes in and the phases out and that. And if you haven't ever had the chance to see one, make sure you make some time for it because it really is something to see. Planets. There are 4 basic planets that you can see without some expensive equipment. And what you're seeing here is Venus, Mars, Jupiter, and Saturn. Now, obviously, they're not to scale here. Venus, of course, because it's between us and the sun, it's always closest to the sun. And so it often appears what looks like a star near the sun at sunrise or sunset. And that's how you find Venus. Mars, which is super cool with any basic equipment, is really easy to find because it's the orangest thing you're going to find in the sky. It is literally that orange looking. And so learning to find it and exploring it with some basic equipment can be a lot of fun. Jupiter and Saturn, a little harder to find, but not bad. You can find them with the naked eye if you know where to look. Jupiter tends to be a little more brown looking than Mars, and Saturn kind of again as well. And with some very basic equipment, you can see some stuff and maybe even see the rings of Saturn. Okay, telescopes. Let's talk about telescopes for a minute. And probably the best thing to start with, and I have 2 sets of these, are binoculars. And we could have a whole presentation on what binoculars are great for looking at the night sky, but I'm going to tell you, the best kind of binoculars you can have for looking at the night sky are the ones you own. So whether it's dad's or grandpa's or somebody else's you borrow, or you go out and buy the $30 set at Crappy Tire, I have two sets of binoculars. I have a little set that goes on a pouch where I take along when I go on hikes and stuff like that that fit on my belt, and I got a big honking set that I keep at home. The beauty of binoculars is setup time is 0. And you can really see some really cool stuff with a set of binoculars that you're taking it to the next level versus looking at the night sky with just your eyes. Some telescope basics. Your L basic telescope is a refractor, which is a fancy word for a tube with lenses in it. Okay. Now what you're seeing here, and you're going to see in, I use the laser. That little part there has a mirror on it. And the reason they put a mirror there is because you're going to point the telescope up and you don't want to have to lie on the ground to look through the tube, right? So they put a mirror so it gives you that 90 degrees reflection so you can look through the eyepiece without having to lie on the ground. Refractors are excellent telescopes, okay? And a lot of people have them. Reflectors, okay. The one on the left is the telescope I own, that one with the big silver tripod, the Celestron. It's got about a 6-inch aperture on it. It's a reflector. And how you can tell a reflector is the eyepiece is at the front. And how it works is the light comes in the front of the tube, reflects off a curved mirror at the bottom, up to a little mirror below the eyepiece that then reflects the light through the eyepiece. And you're wondering, why would you do that? Well, there's a reason for that. One of the very basic physics is the length of the telescope is how much you can magnify with. Just very basic. I'm making this super simple. And by using a curved mirror, you're basically folding the telescope in half. And so you're getting twice amount of length of telescope for the length of the telescope you actually have by reflecting the light back and then looking at it. Okay? The other important thing, and you'll see on the newer version of my telescope, which is sitting on the right, they made it wider. Well, that lets in more light. The wider the telescope is, the more light it lets in, your ability to see fainter objects is better. So 2 key elements: length of the telescope, which may be folded if it's a reflector, and the width of the telescope. Okay. Then you get into the fancier stuff. And so what you're seeing on the one on the left there, that nice one with the orange thing and the little computer that'll track things in the sky for you, is they fold the light again. So it's, I believe they call it a Schmidt-Cassegrain. It goes 3 times. So it comes in the front through a lens, off a mirror in the back, which shines to a little mirror in the front, which then shines to a back through a little hole in the back mirror, and you see the eyepiece back there. So they've basically folded the telescope 3 times to get the length. And you can see it's nice and wide, get lots of light coming in, you can see faint stuff. Then on the right, something else I own that I bought this past year is something completely different again. And that's a digital telescope where it's not your eye doing the seeing, it's a digital chip, which then sends a nice signal to your phone or your laptop and can take some nice pictures for you. And I'm going to do a whole session on what I'm learning with the C-Star S30. And I just got told by Mark Lilienthal today, Jonathan, they have the C-Star S30 Pro now? And I'm like, what, with tint control? Like, what did they add, right? So technology is really advancing in that field. And I imagine 10 years from now, I can't even think of just how much more ability we'll have to look at the sky. Okay. Mounts. I want to talk about mounts. And there's an important point I want to make, but I want to talk about the first 2 types of mounts. The mount you see on the left is actually the actual mount itself, not the tripod, but the mount I have on my telescope, and it's what's called an equatorial mount. So you'll see there's some important parts here. This part here, you line up with Polaris. Cool. And we're about 45 degrees north of the equator. So you set that little gauge at the bottom, 45 degrees, find Polaris, you line that up so that the base of your telescope is lined up with the planet. And then you have the two axes you can adjust, which you see the two weights, the big one, the little one. The beauty of this is that once you point at something and you want to track it, you only have to drive a motor on the upper axis to keep your telescope following what you're looking at. And I have a little drive that goes on the top, on the opposite end of that wheel. Right there, that keeps my telescope looking at what I want to look at. The bottom, you see what they also use with telescopes is basically a fork. They call it alt-azimuth mount. And for tracking, you have to adjust in two directions. And so with modern technology and gears and drives and that, it's not such a big deal. And it's a little easier to set up. The important thing about mounts, if you go out and buy a telescope, get something with a really solid mount. Because when you look at the night sky and you're looking at something that's this wide, and you jiggle the telescope, you're going to take 20 minutes finding it again by adjusting where did it go. I breathed on the telescope and now I can't see Mars anymore. So when you buy a telescope, telescope's great. Look at the mount. Make sure you get a really solid mount. All that being said, as Paul mentioned before, we have the Ted Bean Loan Library that Peter runs and runs around town bringing you telescopes. Try before you buy. That's one of the great things of being a member of this club is you can try before you buy and play with different telescopes and find out what's the price range you want to spend on a scope, what's kind of stuff you want to work with, how complicated you want it, or you want it to be really simple. Okay, so don't be afraid to reach out and sign out a telescope from our loan library. All right, reference material. This is really simple. There is a book that is the Bible for amateur astronomers starting out, and it's called Night Watch by Terry Dickinson. Now, he's not around anymore, but he was a very famous amateur astronomer in Ontario, wrote articles for the newspapers in Toronto, wrote a lot of the material for RASC, and he wrote this book back in 1983. And I have the second printing, which is the one on the right that says Night Watch, which I got as a math prize in grade 11, and I'm not a young man. Okay, this thing has been printed 30 times into practically every language on the planet, and it's in 5th edition. It has in there everything you're going to need as an amateur astronomer starting out. It talks about the planets, talks about star clusters, talks about galaxies, and most importantly in all, it has these fantastic star charts. One for each season of the year. And on the left, it shows you what you're going to see if you look up at the sky. And on the right, it tells you what you're looking at. And so we're going to have a bit of fun with this because we're looking at the winter one. And guess what we see? Right there is the Big Dipper. And it points over to Mars, which is right there. And the Little Dipper. And if you go a little bit to the right, down there you see the Milky Way, and you see Cassiopeia, or Cassiopeia, depending. And you follow the triangle, and if your eyes are really good, you'll see the smudge, and that's the Andromeda Galaxy. And then down here at the bottom, la-di-da, you find Orion. And guess what? You get those sorted out so that you can find them fairly easily. You pretty much got how to look at the northern sky. And on the right, you see the chart of everything that's going to be there. And then the book, it has breakdown charts for each area of the sky. So this is a fantastic book. It's coil bound, which is super handy because you just open it up, flip it around in the pages you need. And guess what? I do believe we have copies in our loan library. Now, this is where I get to do a little see if I can't recruit someone. But for those of you who have been members for a long time, Estelle has worked really hard forever and ever and ever and ever, and finally said, you know what, I think someone else needs to carry the torch. And you know what, so we really need a librarian. So if someone wants to step forward, put their hands up, reach out to any member of council, we would love for you to take over all the hard work that Estelle's done and help with some of our new members and getting some of this great reference material to them. And there's lots of great stuff in there, including The Night Sky by Bob King. No relation at all. Bob is not my uncle, okay? software applications. I'm only going to talk about what you put on your phone because I don't know about you, but I've tried doing astronomy where I slept my laptop outside at nighttime and now I need a new laptop. Okay. Um, there's a lot of fantastic free applications. I think these are all free. I can't say for sure. I have Star Tracker and Stellarium on my phone. And the beauty of that is it's got all the sky charts on your phone. And as you take your phone and you move it around, the sky charts change and tell you what you're looking at. So isn't that handy? Makes the reference material that much easier, okay? So all told, if you can take all this and put it together, if you've never done astronomy before, these four things, just getting a handle on what's in the night sky, in the northern sky, finding a basic telescope or set of binoculars to start peering at stuff, getting a copy of Night Watch or something like it, and maybe an app on your phone, you're well along the way becoming a really great amateur astronomer. All right. Any questions? No? Going once, going twice. Paul, back to you. Thank you. I might have done one or two over the years.
Thanks, Jonathan. Astronomy 101. All right. We do have some observation reports, as I grumbled about earlier. November and December have been pretty cheesy on giving us some clear nights, but there have been a few here and there. And the benefit of those cloudy nights is we get a chance to process the data that we shot on the clear nights. So this is a good thing. So first up, we have Jim Thompson. Oh.
All right. Might as well just repeat what he just said. Yeah, December sucked. If it wasn't snowing, then it was cold. If it wasn't cold, it was just cloudy. But I did get out twice. The first image was on a Saturday or a Sunday early in December. And I heard a rumor, it was going around the internet, that there was a massive sunspot. Everybody get outside, look at the sunspot. So I said, okay, well, I'll go out and take a look. And indeed, it is one of the largest sunspot groups that I have seen this solar cycle. It was huge. The Earth, for comparison, is about the size of the penumbra there on that spot. So huge. And I was especially happy to get this good of a shot of the sunspot because right now the sun is incredibly low in the sky. At the time I took this picture, it was, I think it was around noon, and it was at its highest in the sky, and it was just clearing my hedge. In fact, last winter, in preparation for this thing, maybe trimmed the hedge a little lower than I should have, but. So yeah, that was a good catch. I was happy with that. And since then, I haven't really seen the sun much, so maybe January. Perhaps the reason why December has been a cloudy month is that I bought another mini refractor. This is the third mini refractor sold by Ascar. It's the smallest of the three. There's a 203 millimeter focal length, 180 millimeter focal length, and then this one is 135 millimeter focal length. The aperture is 35 millimeters, so this thing is tiny. And I did get out once to try it out. And I did a full observing session, but I only have included one image here, and that was of the California Nebula, which around the 8th of December, it was fairly well placed in the sky. So I was pretty happy with that. Nice pinpoint stars to the corners. Very easy to use, nice firm helical focuser, a great little inexpensive refractor. It was on sale half price, so it was like $300. So excellent for I think it's a quad element apo refractor. So that was my only other observing session for December. And my final image is a shameless self-promotion. Because of all of the free time in November and December with the cloudiest skies, I've decided to go back and look at all of my presentations from the past, going back, bordering on 10 years now, and kind of revigorating them, republishing them as videos on YouTube. So if you have any interest in seeing any of that stuff, especially the introduction to filters, it's a 4-part video series. You can find that at the Abbey Road Observatory on YouTube. And that's it. Thank you.
Thanks, Jim. Great. Bob Olson, who is going to talk to us via Zoom. Have we got Bob online?
I hope so.
Oh, there you are, Bob. How are you?
Very well, thank you.
Happy New Year.
Happy New Year to you too.
All right, I'll leave it to you.
Okay, this nebula is called the question mark nebula, but my field of view was way too small, so I only have one part of the question mark in the image. It's about 3,000 light years from Earth. The nebula glows because of the intense radiation from very hot young stars embedded within the nebula. One of the stars is the hottest one known within 3,000 light years of the sun. The NGC catalog starts at RA0 and continues to increase its number until it reaches all the way around to RA24, 24 hours. The question mark nebula is very close to RA0. When the catalog was first created, it was on the high side of the celestial meridian, so it had one of the highest NGC numbers. But because of the Earth's precession, it has now wandered to the other side of the celestial meridian. So in fact, it should be one of the lowest numbers in the NGC catalog. Next slide, please. This open cluster is sometimes called the salt and pepper cluster, an incredibly appropriate name. It contains about 500 stars and is 4,500 light years distant. Next slide, please. I have imaged the Wizard Nebula before, but this image added 8 more hours to the exposure. So it is significantly deeper than my previous attempts. The discovery of this nebula dates all the way back to 1787, when the famous Caroline Herschel first logged it. Next slide, please. This nebula is both a reflection and emission nebula, although the blue reflection part is pretty faint. This nebula is about 7,500 light years distant. This nebula was first logged by William Herschel in 1793. William is Caroline's brother. Next slide. This nebula is about 7,100 light years distant, and I used about 3 hours of exposure to take this image. This is not really enough data to get a good image, so I am nervous that the background colors may be a little wonky. Next slide, please. This fascinating reflection nebula is found in the constellation Orion. It is about 1,350 light years distant and is fairly bright at magnitude 8.3. This is a red-green-blue image, so the blue is not false color. I find the blue reflection nebulas some of the prettiest objects in the night sky. Have a great day. Thank you very much.
Thank you, Bob. That's some nice work there. All right. Whoops. I didn't do that. There we go. All right. I did manage to get a few nights in. Took advantage of them when they came about. But my observation for November and December is that even on the clear nights, as already mentioned, either the moon was up or the sky wasn't all that clear. There was a lot of, I found this in the last couple of months, those clear nights were often beset with low-lying mist, and that it certainly wasn't clear. I do measurements of the sky darkness when I do these imaging pieces, and typically what I found is on the clear nights in November and December, I'm probably half a magnitude brighter than I would be at other times of the year. So, and that's due to that low, intermittent, and variable haze that seems to accompany the weather patterns this year. However, did manage to cut through a bit of that, and last month I know we had a request for more moon images there. So this is a moon image that I shot in November, a high resolution view of the moon. Specifically, there we go. No, I want to back up on that one. There we go. Specifically, one of my favorite regions is the South Polar region for a number of reasons. This region is really difficult to image and to observe and to identify features on, because the degree of foreshortening, because these things are on the very limb of a spherical structure, the degree of foreshortening makes these craters that you can see lining along near the edge of the illuminated portion, makes them look very flattened. Most of them are perfectly circular if you could look at them from above. So things get very foreshortened. The distances along the lunar terrain become very, very small in comparison to when you're looking at something near the center of the moon's disk. And so the South Pole region is certainly an interest of mine, as we've talked about in the past. Jim and I had did a presentation on some of the features down there, including mountains that you can see on the other side. This is what makes the South Pole region for me particularly interesting, because when the libration, in other words, the tilt of the moon in latitude is just right, you can actually see slightly over the back onto the back side, and on the back side are some of the highest mountains anywhere on the moon, and they actually will poke up into your view if the conditions are just right. To complicate this, though, the best time to see these features near either the North or the South Pole is when the moon is nearly full, because of the foreshortening. The shadows at any other times are very extreme, and they'll hide complete craters, like they'll be in the dark, even though they should be visible. The shadows are extremely long at that point in time. So if you want to see slightly over the backside there, it's got to be illuminated correctly so that you can see these features. The other reason for my interest in the South Pole is that it is the primary destination for future manned landings, which will come up in the next little while. Both the US and China are very eager to set boots on the moon again before 2030. So that's only a few years downrange. And the other reason is very current. Within the next month or two, or possibly 3, depending on how well things go, Jeremy Hansen will be on the Artemis 2 mission, which will actually orbit, it won't really orbit the moon. It'll take a 10-day journey out to the moon, around the backside, and then sling around for a free return back to Earth. So very exciting stuff. Earliest possible date for the launch, I believe, is February the 7th. So less than a month away, if all things go well. They're ready to roll out the spacecraft if they haven't already done so. But so they're eager to launch this mission. Artemis 1 was an unmanned version of this, his first test of the Orion spacecraft and the SLS rocket that will take it to the moon. And so Artemis 2, with Jeremy on board, hopefully, will be the first crewed mission to the moon, and he'll go where no Canadian has gone before, which is really cool. It'll be the first time people have been out to the moon since the 1970s, which is kind of unfortunate. Anyway, so I'll keep looking at the moon, and I shot this image through a bit of a marginal sky using a near infrared filter to smooth out some of the seeing, because the seeing has also been, for the most part, below average in these last couple of months. All right. Next one was one of our challenge objects, Messier 77. This is an interesting galaxy to look at, and even more so to image, as you'll see. This is what you typically might see through a reasonably powered telescope there, basically a face-on spiral. But this galaxy, as I said, is somewhat unusual there. The bright part that you see there now is fairly easily viewed through an adequate telescope, and also imaged with relatively short exposures. Where this gets really interesting is if you do a deep exposure of this galaxy, because what you see is that the galaxy is really a lot bigger than it looks. There is a whole system of complex arms. It's pretty tightly wound, as you can see there. But these are very faint arms compared to most spiral galaxies of a similar form. So quite an interesting object there, and this was a product of 6 hours of total integrated exposures. All right, next on the go. Last month I showed you this image of comet C25K1 Atlas. It was interesting because it had just started to fracture. And this was 4 days before its closest approach to Earth. It was moving across the sky very quickly at this time, so you wanted short exposures, or you had to be able to track accurately on the comet. And so I was lucky to get this because, again, the number of clear nights in November was pretty low. I just happened to get a clear night when this shortly after this fracturing had occurred. I shot it again a week later on the 27th. This is 3 days past its closest approach to Earth, and you can see that the smaller fragments that had broken off the main body had completely disintegrated, and you were left with the main object still readily visible. All right. The other comet I've been chasing since last July, when it was discovered, is our interstellar visitor, comet 3I Atlas, only the third known object to enter our system, but at least that we know of, since the original discovery of Oumuamua. This is rapidly moving away from us. It's moving much faster than most comets. It's already about halfway between Mars and Jupiter after rounding the sun in October. From our latitude, we really and given the geometry of the comet with respect to the sun, we couldn't really image it. I certainly couldn't have a view of it until November the 14th was my first date where it actually cleared my trees before dawn started. So this was on November the 15th. I was lucky to get that date. And then again on December the 28th. Actually, and I want to back up on this one a little bit. Sorry? Oh, I'm sorry. Oops. Wrong button. All right. Okay, I'll give one to myself too. I just wanted to mention special thanks to Andrew Brown, who I think I just lasered, and Taras Rybarski. On the December the 18th, when I was shooting this, I got an email from the guys saying that they were going to go to FLO and work on the 14-inch Schmidt out there. I'd already had this project in mind. It was, again, one of the few clear nights in December the 18th. So I couldn't join them that night, but they sent me the results. They went out and they had the same type of clear night that I had for this object. And I just want to thank the both of you for the work that you did on the 14-inch because it's remarkable. Like the data that they sent me, they took some before and after images. They were working on the collimation of that scope, which seems to have become a bit decollimated since the last time I adjusted it about a year and a half ago or so. And the improvement based on the data that they sent was remarkable. So hats off to you guys. That was a really nice piece of work, especially considering it was freaking cold that night. And they were out in the dome tweaking and poking and looking at computer screens. I had the benefit of sitting in my warm room by my observatory, so I got spoiled that night. But no, they persevered, and looks like they nailed the collimation pretty nice. So again, thank you so much for doing that. That was not a fun night to be standing around outside, and just 2 thumbs up. Yes, yes, please. All right, I'll try not to laser you, especially after what I just said. So that was on December the 18th. Again, I've been tracking this comet since July, and it's now rapidly moving away from us. I shot it again 12 days ago, which was the last clear night I had. It's dropped about a magnitude and a half from the image I just showed you there, and it was noticeably dimmer. This was actually a clearer night though, so it's almost comparable in brightness. Same camera, same telescope. But it was definitely not as hazy, and managed to snag this image of the comet and a 15th magnitude PGC galaxy up in the top left corner. So yeah, it takes the nights that we get, and that's it for me. Thank you, Richard.
Hello.
Oh, he's with us online. Okay.
I'm online. Yes. Sorry. I didn't feel like coming out in a damp night tonight. So very sorry, but I didn't get the usual challenge object of the constellation because I didn't get out to FLO this month. I been suffering from the cold and didn't really want to drive all that way. And the last time I was out at FLO, it was that very misty night, and I didn't get any observing done anyway. So no picture of the constellation, and my backyard is not the greatest view towards the south. There's an apartment building, there's lots of trees. So I only had a very brief opportunity to get some pictures of the level 2 challenge, M77 and NGC 1055, very close to the bright star Delta Cetus. Next one, please. There was even a briefer opportunity to capture this very faint planetary object. This is sometimes known as the Skull Nebula or the Soap Bubble Nebula. I think the Soap Bubble describes it best because it's a very faint, wispy little planetary nebula. Not too small. It's fairly big, but just a very, very faint bluish tinge to it as well. Next one, please. And I did suggest that people take pictures of the moon, and we did get quite a number on the Discord server. Because I wanted to show what it's like to take pictures of the moon, I used my simplest equipment for this picture. And in fact, I just aimed my mirrorless camera with its long telephoto lens, it's a 300 millimeter zoom lens, through the kitchen window, which has got a screen on it. So I'm not saying that this is the best way of doing it, but this is what you can get with a snapshot of the moon. And as I said last month, it's not difficult to get the settings for the moon because it is really like a sunlit beach. So you use the same kind of settings as you would for a sunlit beach, and it will show up with a good exposure. And generally the camera can autofocus on it because it does have a sharp outline and features that it can detect. So it's not a difficult object to take a picture of. And if we go to the next picture, This is the same photograph that I have cropped a bit and just done a very little bit of enhancement after the fact, sharpening using a standard sharpening tool and adjusting the brightness a little bit. But again, this is a great object to start your astrophotography on, because it's similar to objects that you take on Earth, but it's got the challenges of getting the exposure right, getting the contrast right, because there is a lot of difference in brightness between the terminator, where the Earth, the shadow of the moon is coming round, and the brightest parts which are in full sunlight. So I'd strongly recommend that people who are interested in astrophotography get started on the moon. Next one, please. Now, for my own challenge purposes, I'm planning a trip to New Zealand later in 2026 in March and April. And the main purpose of the trip is to see New Zealand and see some of the sights there. But I did want to also take the opportunity to get some shots of the southern sky, which I really haven't had much experience with. So because we're going to be traveling around a lot, I didn't want to have to bring along all of my usual astrophotography equipment, which basically fills the trunk of my car. So I looked around at various options and decided that the Seastar S30 was probably a good idea, being so small and portable. So I ordered one and it arrived like 2 days before Christmas. Sorry for the weather. And I started taking pictures with it. And I am very, very impressed. I'm very favorably impressed with this telescope, mainly because of its ease of use. There was the general thing that you always have to do about, downloading the app, making a password, and connecting online and that kind of thing, which we all have to do, seems like every couple of weeks now. But the actual telescope itself was basically take it out on the back porch, plonk it down on the deck. I didn't, go to any extremes about trying to level it or put it on a solid surface or anything like that. Push the button and then run back inside and connect to it with my iPad. So I could sit in the nice warm comfort of my easy chair beside the fireplace and control it from there. This is the first picture I took with it. This is the Triangulum Galaxy M33. And this telescope and its app does what's called the live stacking. If any of you have seen me at the recent star parties, I have been doing live stacking using my bigger equipment. But this telescope is completely automated to set up for it. You choose your object, you click and say start, and it starts. And you see a very faint, blurry picture at first, and then it gradually gets better and better and better and better. And this one I left out there for 70 minutes, and this is it. Then I use the online tool to just do a bit of brightening, a bit of sharpening, a bit of noise reduction. Again, it's all very, pick from a menu and it does it automatically. So, as I say, very, very impressed at my first impression of this equipment. Next one, please. Now, this is my second attempt. This is Caldwell 31. This is the Flaming Star Nebula, which is one of the challenge objects from a couple of months ago. And this time, instead of using the built-in tools, I actually took the raw data, which are 10-second exposures. I was using it in alt-azimuth setting. And I took I think it was 530 raw images, and then restacked them using PixInsight and did my usual steps of sharpening and processing and brightening and color balancing and all these kind of things that I normally do with my astrophotos. And this is the result from, I think this was a 90-minute stack of pictures. So that was a lot of work. That took me like, 2 or 3 hours of post-processing to get this. But the next picture shows what came out of the Sea Star and its own built-in app, which is still pretty good. So once again, I'm quite favorably impressed with this equipment and with the software that comes with it for both taking the pictures and, making a fairly pretty picture afterwards. So I'm now looking very much forward to my trip to New Zealand, and for probably the May and June meetings, I'll be showing some of my observations of things in the Southern Hemisphere. Okay, I think we can move on to the monthly challenges. Yes, okay, so these were the challenges for this last month. Constellation Cetus. I did try and capture the star Mira, but I couldn't do anything about the variability measurements because there were no stars nearby to compare it to. It was in its fairly faint part of its cycle during this last month. So it was not a very impressive object. Messier 77 we saw, 62, I'm sorry, I didn't get it. I didn't see any other pictures on the Discord server either. 56 was the planetary nebula, and as I say, we did see many pictures of the moon. Next one, please. It was not a great month for observing. we did have Mark Lilienthal and Xavier both got pictures of M77 and NGC 1055. And as I say, a couple of pictures of the moon, but not much else. So let's hope we get more clear skies in January. Next one, please. And similar to Jonathan, I thought this month would be a good one to get people started on, their observations of the night sky. And one of the best things to start with is the Big Dipper and the Little Dipper. So the Little Dipper is, very easy to observe from Canada because it's always in the sky. It's so far to the north, and we're at 45 degrees latitude here, so it's nicely placed for just look up, and you're looking in a good direction and a good time to see everything. Now, this month, the Little Dipper is sort of hanging by its handle. It's like it's hanging on the wall, the dipper hanging down. This is what it was like in January. And then at different months of the year, you'll see that it rotates around Polaris. Also during the night, it rotates around Polaris. If you watch for many, many hours, you will see it gradually moving. Now, the interesting thing that Polaris has is, the interesting thing that the Little Dipper has is Polaris itself, and also that the stars in the Little Dipper are of various magnitudes. So it becomes a kind of test of the seeing conditions, the light pollution conditions, and your eyes too. So Polaris and Kochab, marked on the map here, are both about magnitude 2. Now, be careful here. Magnitude 2 is reasonably bright. You should be able to see it even from the city, but it's not the brightest thing in the sky. I often had that confusion come up with my students when I was teaching astronomy to grade 9 classes. Polaris is not a very bright star compared to many of the others nearby. It's nothing like as bright as Orion, for example, the stars in Orion. So it's bright enough to stand out in its area, but it's not going to be eye-catchingly bright. Kochab also, as I say, equally bright to Polaris, magnitude 2. So if you can see Polaris, you'll probably also be able to see Kochab, and fairly likely the other star at the end of the bowl of the Little Dipper, because that's magnitude 3. The other stars in the Little Dipper are fainter. So the one at the joint between the bowl and the handle of the dipper is magnitude 4 or 4.25. And then the fourth star in the bowl of the Little Dipper is magnitude 5. So if you can see all 4 stars in the bowl of the Little Dipper, that means you've got a pretty dark sky and the seeing conditions are pretty good. The other stars in the handle of the Little Dipper are about magnitude 4 also. So I'd like some people to try and do observations of the Little Dipper from various places around Ottawa or just outside Ottawa. And maybe you could post it on the Discord server or tell us next time at the meeting, how many stars in the Little Dipper can you see from your conditions? And it's a kind of test of the light pollution and visibility through the sky that you can see that night. Next one, please. So the other challenges this month, Polaris itself. If you got a new telescope for Christmas, or if you're trying out some of the things that Jonathan was talking about, polar alignment, you'll need to do a little bit more care about finding Polaris, aiming the axis of your telescope mount towards Polaris, and then you'll start noticing that one of the things he said was not quite true. Polaris is not exactly at the North Pole of the Earth. It's about 2/3 of a degree away from it. So if you really want to get your polar axis aligned properly, you'll need a little telescope to aim along the axis and aim just a little bit away from Polaris. Once again, January is an interesting month for this because Polaris is just a little bit above the pole. But at other times of the year or at other times of the night, if it's a bit later, earlier than 8 o'clock, then Polaris will be in different directions away from the actual pole. So that's something that you should also be investigating. That's my level 2 challenge for this month, is figure out polar alignment. There's a lot of instructions available online or in the Observer's Handbook about how to do this. I think I'm going to have to learn something new this month because the C-Star S30 uses yet another way of doing polar alignment that I need to learn about. For the level 3 challenge, Caldwell number 1, the cluster of stars that is closest to the pole. Officially, it's not in the constellation of Ursa Minor, it's in Cepheus instead, but it is the closest star cluster, open cluster to the North Pole. And then in the third star of the handle of the Little Dipper, there's a pair of galaxies, fairly faint, but an interesting combination of, I believe it's an elliptical and a spiral galaxy, fairly close together. NGC 6251 and 6252. And then for the solar system challenge this month, take a look at Jupiter. Tomorrow night is when it's officially at its opposition, meaning directly opposite the sun in the sky, which means it's visible all night and very high at midnight. Great time to look for the cloud bands and the Great Red Spot. For the Great Red Spot, I'd strongly recommend that you look at the Sky and Telescope magazine. That they have tables every month of when the Great Red Spot is going to be visible. And there's an online tool which will be available in the Astronauts this month. They put a link to their tool that calculates when the Great Red Spot is visible. It's not as easy as you might think because Jupiter rotates differently at each different latitude. So the Great Red Spot has its own particular latitude and its own particular cycle of visibility. Okay, there's your challenges for the month. I'll see you next month. Thank you.
Thank you, Richard. All right. So as we've mentioned already, we are seeking a new librarian for our collection of astronomy books and other paper-based information in the back. If you are interested, we would certainly appreciate hearing from you. So until we get that position settled, I guess we'll have to leave the library closed for now. All right, Fred Lossing Observatory, just a reminder, it is available to all members, and we do clear it in the winter as much as we can, so it is accessible. FLO Star Parties, our first one is scheduled for January the 17th, weather permitting. And you can see the list there as well of the upcoming star parties scheduled for the rest of the year. And again, these are for members only. For club information, you can contact any one of these people depending on what it is what information you're after. And again, thank you for attending tonight. We had 49 folks at the museum tonight, and almost an equal number on Zoom, so a total of 94 viewers. And again, thank you for all the images and the presenters and the time that they've invested in doing their images and their presentations. And we would like to thank again the RASC National Office for the Zoom capabilities. Any ideas for meetings, for observations, for presentations, feel free to contact me at the meeting chair email address at the bottom. I am currently looking for presentations into the middle of spring. We're pretty much scheduled, I think, until May. So I have a few irons in the fire for that. So if you are interested in putting something together, please don't hesitate to call me, because I do like to schedule presentations as far in advance as possible, typically 2 to 3 months. So yeah, let me know if you've got something that you'd like to talk about, and we'll see if we can get it going. Our next meeting, you may have thought, or we may have said previously, that it was on I think February the 8th or the 7th. It has been rescheduled, and in part, the reason for that is what I mentioned about the possible launch of the Artemis II, which is scheduled currently, again, the earliest time I believe is February the 6th or the 7th, which was the date of the original February meeting. So we are pushed back a week to the 13th. All right, and thank you again for coming. I wish you clear skies. I know that talking to a number of you, I understand perfectly the reasons that we've had such crappy weather, because Christmas had just come, and I'm guilty of that too. There's toys that were under the tree that are ready to be used. All we need is some clear skies. So I'm wishing you clear skies this month. Be safe on your journey home, and we'll talk to you next month. Thank you. Oh, yes. One final note, we will be going, if you're interested in the post-meeting meeting, a few of us will be going to Liam McGuire's down on Saint Laurent for that. All right. Hail Canada.
Something. Yeah.